In hematology analysis, you can't afford to compromise on quality or accurate results. Our analyzers and process has been tried, tested and optimized for decades, giving you more robust and reliable hematology systems. The blood analysis is started by aspirating 110 microliters of blood sample that is transferred to the shear valve. The high-precision, maintenance-free shear valve cuts a precision volume of 22.5 microliters that is used for analysis. The diluent pipette will dispense 4.5 milliliters of diluent controlled by an air pump. Once the diluted sample reaches the mixing beaker, it will have a 1 to 200 dilution. This is the first step in the dilution process. From here on, the diluted sample is divided into two different paths. They both go through a second dilution process using pipettes, featuring optical sensors guaranteeing an accurate volume. No pistons, motors or gearboxes are used in the diluting system. Just an air pump and a vacuum pump is used for dispensing the reagents to reduce the maintenance and service needs. For red blood cells and platelets, the first dilution is aspirated from the mixing beaker through the shear valve, cutting out a volume of 22.5 microliters. The diluent pipette dispenses 4.5 milliliters of diluent, making the second dilution that reaches the RBC measuring chamber to a final ratio of 1 to 40,000. For white blood cells and hemoglobin, the first dilution is diluted with the same volume of lyse, dispensed by the lyse pipette. The second dilution of 1 to 400 is transferred to the WBC measuring chamber. In the measuring chamber, the lyse hemolyses the red blood cells, releasing the hemoglobin while simultaneously shrinking the white blood cells. Here you get a three-part differentiation of the white blood cells, allowing measurement of lymphocytes, mid-cells and granulocytes. When the hemoglobin is released from the red blood cells, it's possible to measure it by the absorption of light in the measuring chamber. The level of light absorption correlates to the hemoglobin value. The air pump generates a pressure that pushes the final dilution through an aperture in the measuring chamber. Each cell passing the aperture will generate a pulse. The number of pulses represent the concentration of cells, and the amplitude of the pulse represent the size of the cell. This is known as the impedance method. During each counting cycle, a precise volume of 270 microliters of the final dilution will be analyzed in both measuring chambers. The volume is controlled by the measuring tubes. When the liquid passes the optical path of the start sensor, the counting is activated. When the liquid passes the stop sensor, the counting is finished. Using an absolute volumetric method will be the most accurate and robust way of controlling the count cycle. A high-voltage burning of the orifice will automatically be carried out only when needed, all to reduce wear and tear. In the end, you're presented with clear histograms and accurate values for the different parameters, all within a minute.